Hi everybody, welcome to another video in Trigonometry, section 3.1, Radian Measure. So up to this point on the calculation, the way we set up the calculator, everything has to be in degree. By the way we do that, in this calculator we hit mode, and that should be in degree up to this point. Now we define different unit to measure angles, and that is the radian measure. So how do we define that? Right, so definition, an angle whose vertex is at the center of the circle is called a central angle. Right, so nothing new here. I just have an angle at the center. The vertex will be right at the center of the circle, so that's the central angle. And we define the radian as follows: a positive central angle formed by rotating the initial ray through an arc of the circle length equal to the radius of the circle has 1 radian. So what did that mean? So think about that. If we have a wheel, a circle, I will draw a circle. So let's say we have a circle like that. The radius is that much. Now, imagine that this is a wheel. If you're rotating on the ground, if you roll that circle along the ground, of course, the edge of the circle will touch the ground. Let's say this is 1 foot, the radius. Will rotate so that it will roll is also 1 foot. In that case, if the arc length is the same as the length of the radius, in that case we define this as 1 radian. But then you say exactly how long is 1 radian, right? So now I remember the way we write this is in terms of the arc length and in relation with the radius, right? So, and then after that we also have a central angle theta intercept an arc length s in the circle of radius s is given by this. So the measure of the angle is given by the ratio of the arc length over r. Right, now, so now how much is 1 radian, you ask? Right, think about this. If we rotate the whole circle, so we have 1 revolution, obviously it's 360 degrees, right? Right. Now, the angle is equal to the arc length divided by the radius. Now, if it is 1 revolution, the arc length, so I write this here. So for 1 revolution, the length of the arc is equal to the circumference of the circle. Circumference of the circle is 2 pi times the radius, right? Now, the angle is equal to the arc length divided by the radius. So for 1 revolution, theta equal to s over r. So theta equal to s is the circumference 2 pi r divided by r. R and r cancel. So that's why for 1 revolution, s is going to be equal to 2 pi. The unit for that is radian. Now, the radian is unlike other unit. We can just put it in or take it out without any problem. So I can write 5 radian is equal to 5, and that is not wrong. The radian is not really a unit. We can just put it in, take it out. It doesn't affect anything at all. Right. So or you could say by default the radian, any unit, if it's just a number, that the unit is radian. That would be perfectly fine. You can put radian in or take it out as we want to. By default, if it didn't say anything, it is the radian. Unless, of course, we specify the degrees, and that's different story. Right. Anyway, so 1 revolution, 360 degrees, 2 pi radian. Now, if we give that ratio, we said, what if we want 1 radian? Then is equal to, what is the degree there? Let's instead of put a question mark, let's put x in it instead. Right, x degree equal to 1 radian, equivalent to that. Now, we just set the ratio and proportion. And cross multiply. And we solve for x. So I will write that over here. So we have 2 pi x is equal to 360 times 1. Again, the radian, I just didn't take it out when I want to. Degree cancel out. So to solve for x, we take 360 divided by 2 pi. So if we say 360 divided by 2 pi, make sure it's in the parentheses. So it's about 57.3. The nice thing about radian is, if we want to, we can take it out or we put it back in as we please. So it's still fine. So and then sorry, there's something off here. Yeah, so x is about 57.3 degrees. Yeah, if x degree is, so x is equal to 53. So the conclusion is 1 radian. Sorry, that was completely. Yeah, x is the unit is degree. So we say 1 degree. 1 radian is 57.3 degrees. Right, but we don't have to memorize that. Since 2 pi radian is equal to 360 degrees, divide everything by 2. We have pi radian is equal to 180. This is what we need. We're going to use that and only use that. Don't need to do all of this or memorize that. So pi is equivalent to 180 degrees. Like I said, we don't even need to specify radian. We say pi is equal to 180 degrees. Because radian is the special unit. You can take it in, take it out, or put it back in. It doesn't matter. Right. Now, how do we convert between degree and radian? And that pretty much all the focus on this section is conversion between degree and radian. How do we do that? All right. First, 30 degrees. Right. Now, it's just like any conversion. We would write the conversion factor. We put a fraction. Let me ask you this. What is the question? Convert each angle from degrees to radian. So the answer is in radian, right? If the answer is in radian, we're going to put the radian on the top, and we'll put the other one at the bottom. If we want degrees, we put degree on top, radian at the bottom. If we want radian, put radian on top, degree at the bottom. Right. Now, the degree and the degree cancel out. 30 divided by 180. 30 divided by 180. Convert to fraction. It's 1 over 6. So if you combine the numbers 30 and 180 divided by 180 is 1 over 6. And we still left with pi radian. Again, radian, we can keep it there or take it out if we don't want to. So just say it's pi over 6 or just pi over 6. Alright, so that is where we convert from degree to radian. Right, negative 210 degrees. Now, again, if we want radian, we put pi radian on the top and 180 degree at the bottom. Degrees cancel out. 210 over 180. And convert that to fraction. 7 over 6. Yeah. So if you just do the math here, 210 and over 180, that is 7 over 6. And then we still have pi radian. Yeah, so 7 pi over 6. Right. Again, if we want to convert degrees to radian, we're going to put pi radian on the top and 180 degrees at the bottom. If it works out, the degree will take care by itself, like cancel here, and 75 over 180. Convert to fraction. 5 over 12. And then don't forget there's a pi radian. Or we could just drop the radian. Right, because radian is the type of unit where we can put it in or take it out. And then 120 degrees. By the way, don't forget there's a negative here, right? Sorry, don't forget that. Now 120 degrees. We have pi radian on the top and 180 degree at the bottom. Degree cancel out. 120 over 180. That is 2/3, by the way, but two-thirds pi. Yeah, whether we put radian there or not, it doesn't matter. So that's what we have, right? So from the degree to radian, since we want radian, put radian, pi radian on the top and 180 at the bottom. And likewise, doing the opposite direction, if we want radian to degree, we start with the original problem. If we want degree, we put degree on top. So 180 on the top. The bottom is pi radian. Like special unit, right? Just take out. It cancels itself. Alright. Now simplify pi divided by pi, cancel out. 180 divided by 6 is 30 degrees. Simple enough. Once again, if we want from radian to degree, by the way, the reason it cancel itself is by default pi over 6. We can have the radian, and that radian cancel with this radian, right? So usually if it's radian, we don't really need to write a radian. We just put 180 over pi. So it's 180 over pi. We don't even need to write the radian. But we want degrees, so degrees should be on the top. Cancel out. 180 divided by 6. That, of course, I have to write the correct problem, right? -3. Yeah, so I have -3 times 180 divided by 4. Yeah, that is correct problem. Sorry. Just copy that. Anyway, -3 times 180 divided by 4. So that is -135. Right. By the way, you should be familiar with these values. So that's why we have this exercise. Right. So once again, if we want degree, put 180 degree on top, pi at the bottom. If we want radian, put pi on the top, or pi radian on the top, and 180 degree at the bottom. What we want, put on the top. What we don't want, put at the bottom. And then it should cancel and take care by itself. So that should be very straightforward then. Right. Now, I did mention that you should get used to this. Okay. Now, the circle, 1 revolution, 260 degrees. So let me bring that closer to the camera. Right, that's a little bit better. Right. Now, of course, if it is, from now I write 0 is inside, degree, and on the outside, equivalent in radian, 0. 0 degree, 0 radian. Simple enough. Next, 30 degree for this point. Equivalent to that is pi over 6, which we did. Now, and the rest, that 30, and then will be 60, that 45, 90, 120, 135, 150, and then 180 inside. Right, so what do we have these values? So first, half a revolution, 180 degrees. Divide in half, so that's 90, that's easy. Then divide that into 3 equal pieces, so 30, 60, 90, 120, 150, right? And then 90 degree, if we cut in half, that will be 45, that is 135. So that's what we have. Next will be 210, 225, 240, 270, 300, 315, and 330. Those are the values on the circle, right? In the standard position. Now, equivalent pi over 6. Now think about this. This length is, one of them is pi over 6. So we have another pi over 6, another pi over 6, another pi over 6. So let's just say 1 pi over 6. This point will be 2 pi over 6. 2 pi over 6, 2 and 6 cancel out. Pi over 3. Next, 3 pi over 6. 3 and 6 cancel out. That pi over 2. 4 pi over 6. 4 pi over 6 reduced to 2 pi over 3. 5 pi over 6. Well, that is not reduced. 6 pi over 6. 6 and 6 cancel. Just pi. right? 7 pi over 6, that does not cancel at all. 8 pi over 6, 8 pi over 6, 8 and 4 cancel out, that's 4 over 3, so 4 pi over 3. Wait, so 1, 2, 3, 4, 5, 6, 7, 8 pi over 6, 9 pi over 6 reduced to 3 pi over 2, 9, 10 pi over 6 reduced to 5 pi over 3, 11 pi over 6, that is not reduced, and then 12 pi over 6 or 2 pi. Right. So those are the values equivalent to multiple 30 degrees. Right. Next. Now we do multiple 45. 45 degrees. What is 45 degrees? Okay. 45 degrees. Don't 1 degree anymore. So put pi on the top, 180 degree at the bottom. So in that case, degree cancel out. 45 divided by 180, so that is 1 over 4 pi. So 50 degrees is pi over 4. These values. Now, pi over 4, 2 pi over 4, 2 pi over 4, 2 and 4 cancel out, that pi over 2, so which is good. Next, 3 pi over 4, that is not reduced. 4 pi over 4 reduced to pi, which is good. Okay, so 1, 2, 3, 4, 5 pi over 4, 6 pi over 4, that cancels to this, which is good, and then 7 pi over 4. So then we have the special values, multiple 30, multiple 60, multiple 45, and we have degrees, inside, and radian on equivalent of the same point. Right, so that's what we have. Right, so we just write the equivalent. Equivalent to 0 degree is 0 radian. Equivalent to 30 is pi over 6. 45 pi over 4. 60 pi over 6. Pi over 3, sorry. 90 degree, pi over 2. 180 pi. 270, 3 pi over 2. Right. So now we will have update. Update for the right hand rule. So if it is in degree, will be 0, 30, 45, 60, and 90. Now in radian. That's terrible, sorry, but 0 degree, 0 radian, pi over 6, pi over 4, pi over 3, and pi over 2. Equivalent to that. Now just work just fine. Right, and then we find sine, cosine will be the right hand. The rule will work just fine. Right. So 0 degree will be that, and sine is the number of fingers on the right. There's none, so sine 0. And cosine is number of fingers on the left. Square root of that will be 4 fingers on the left of that. So square root of 4 over 2, or just 1. Right. Next, pi over 6. 1 finger on the right. Square root of that divided by 2, so 1/2. Cosine is the number of fingers on the left. Square root of that divided by 2. Pi over 4. Same thing, square 2 over 2, square 2 over 2, pi over 3 or 60 degree. Yeah, so it works just fine, but we just have different values, different unit. So 3 fingers on the left, 1 finger on the 3 finger on the right, 1 finger on the left. 90, 4 finger on the right, and nothing on the left. Right, 180. A little special values. At 180, we can write the values here is we can choose the values of x equal to -1 and y equal to 0, and r. Yes, so 180 degree, x equal to -1, y is 0, and r is equal to 1. So use that, and sine is what? Y over r. So sine y over r, and cosine is x over r. Right, like I said, when all fails, just go back to definition, and that will work just fine. All right, what else? 270 degrees will be here. That point will be 0 and -1. So in this case, for 270 degrees, x is 0, y is -1, and r distance is equal to 1. Sine is x over r. Sorry, sine is y over r, right? And cosine is x over r. Right, so that's what we have. Right, but most importantly, focus on the hand of 0 to 90 degrees, 0 pi over 2 in radian, pi over 6, pi over 4, pi over 3, and pi over 2. Those are the special values that we have the values. And you said, what if we have like 1.5 radian? What if the question is find sine of 1.5 radian? By the way, if 1.5 radian, that's all we need. Don't need to write radian. In that case, just use the calculator. But if you do that, make sure that it is in the radian mode. Then you can calculate sine of 1.5 radian. So it's that, right? So if it is any other values, make sure to calculate in the radian mode, and then just evaluate. Straightforward. So that's why we didn't have any example. The focus here is focus on the special values, 34, multiple of 30, 40, 5, and 60. Equivalently will be pi over 6, pi over 4, and pi over 3. Right. And if there's other than that values like pi over 5 or something like that, use a calculator. Make sure that it is in the radian mode. Right. So this pretty short video. We just need to define what is a radian, how the radian unit works, and the equivalent between some common values in degree and radian. And that's all I want to cover in this section. See you in another video in trigonometry.